Hi, welcome to Math 204 Remote Learning on Monday, January 22nd. We are going to start with the section 2.6.2 notes, which is the region between two curves. So we'll get a good introduction today and then definitely take questions in class when I see you hopefully tomorrow and finish off this lecture then. So far, we have only found the area of a region that is bounded by a single curve. Okay, so that's what you did in Chapter 5 in Calc 1. So now here in Calc 2, we are going to find the area of the region bounded by two or more curves. Okay, so there are two types of integration that we're going to do depending on what the curves look like. First one, we're going to talk about integrating with respect to x. So we'll have a picture similar to what I have posted here. There is going to be an upper curve. So the upper curve, a lot of times they call f of x, and then there'll be a lower curve. So the lower curve, a lot of times they call that g of x, but as we know, names like that really aren't that important. So here is our definition for that. So if we have a function f and g, they're continuous. We can see here, just like the picture shows, that f of x will be greater than or equal to g of x. So f of x is that upper curve. Then the area of the region that's bounded by those two functions on an interval from a to b is given as follows. So we'll use a for area. Okay, and we'll go from a to b. And then I really want you to think about this as the top curve minus the bottom curve. Okay, and we'll be integrating with respect to x. If you want to use notation and call your top curve always f of x and your bottom curve g of x, that's fine. But we'll try to stick with language to help us see what's going on. The main thing is that our integration is with respect to x. Okay, sorry about that. My notifications are popping up on my iPad during lecture here. All right, so we are going to look at an area of the region in two different ways. So we'll use a little calculus, and then we'll see how to actually do this a little bit easier with respect to geometry. So here we have a triangle, and we are going to be using integration with respect to x. So we have to figure out who our top and bottom curve is and what our bounds are on the x-axis from a to b. So first of all, we can see those bounds. They're nice and labeled for us. So our limits of integration, the triangle is drawn from the x value of 0 to the x value of 1. So we can go ahead and start our integral. Okay, so we have a is from 0 to 1. And then we need to figure out who our upper curve and our lower curve is. So our upper curve is going to be this line segment here, that y equals 2 minus x. And then our lower curve is going to be this line segment here, which is y equals x. So since we're integrating with respect to x, make sure that when we subtract our functions, everything's about x. So that's easy to do because of the way that things are written here. So we are going to take our top function minus our bottom function in this picture, and everything is going to be about x. So our top function is 2 minus x, and our bottom function is x. Okay, don't forget your limit of integration. So you put this all together, we have a nice, easy thing to integrate. We have the line of 2 minus 2x. Okay, so when we integrate this, remember to use the power rule to go up a power and reciprocal in front. So 2 goes to 2x, and then 2x goes back to x squared. And you're integrating that from 0 to 1. So really it's just a matter of plugging in 1. So we have 2 minus 1. So the area of that triangle that's shaded in green is 1. Okay, so I mentioned that this actually is a little bit easier if we just, recognize that geometry is definitely in play. We can find the area of a triangle because we have our old friend 1/2 base times height for the area of a triangle. We can easily see the base. Okay, so this would be the base of our triangle here. Okay, so the base definitely has length 2. And then our height is right here. Okay, and we can see the height that's given to us. We can look at the x-axis, so our height is 1 for this. So we can get that matching answer of 1 that we used, that we got using calculus. Okay, so sometimes you can use nice geometric checks like that. All right, so that's what integrating with respect to x is going to look like. So let's also take a look at what integrating with respect to y is going to look like. So instead of going top to bottom, when you integrate with respect to y, you're going to think about right to left. So in this case, the f function, and notice how x is in terms of f of y, okay, because you want your functions to be all about y here. So or at least your curves to be all about y. And then, so this would be on the right side. So, and then you're going to subtract off the curve on the left side here. So this would be our curve on the left side. Okay, and all the pictures give a very similar feel. So in the second picture, this would be on the right. And then this curve that's in red here will be on the left. Okay, and here this curve would be on the right and this guy would be on the left. So if we're integrating two functions, trying to find the area, and the f of y is greater than the g of y on an interval, notice we're looking at our y values. We're going from c to d this time instead of an x interval. Then the area between the curve is going to be given by the following. Okay, so make sure everything is about with respect to y. And rather than using my function language, I'm going to go ahead and use the words again. So I want to think about the right function minus the left function, all with respect to y. So if you like to use the functions f and g, this would be f of y, and then the left function from all our pictures is the g of y. All right, so we're going to look at the same triangle. We already know the area is 1 for this. We've done it twice. But now we're going to use integration with respect to y, and this shows kind of a very important aspect of what's going on. So definitely we can do it two ways. We'll see that the integration with respect to x was easier because whenever we do the integration with respect to y, we have to think about this and the sum of two integrals because who is on the right changes as you move up the y-axis. So speaking of that, I'm going to show that as we cross this y value of 1, that's where we see that who is on the right changes. So as we move our way up from 0 to 1, y equals x is on the right side. Okay, so go ahead and highlight that. Okay, but then the minute that we cross over and we cross that 0.11, then we have a different function that is on the right side. Okay, so it's the y equals 2 minus x that ends up being on the right side. Okay, so we can definitely see who is on our left side. On our left side is this portion of the y-axis. So I'll go ahead and highlight that. So that is not going to change. That is going to be our left. Okay, so since it's the y-axis, we just have the equation x equals 0. One thing you might want to do before you set up your integral So we're going to have an integral from 0 to 1, and then we're going to have another one that goes from 1 to 2. Since everything needs to be in terms of y, you might want to go ahead and make sure that your lines are in terms of y. This first one is okay. This one is not very hard to do. We just need to switch the roles of x and y. So if you switch their sides, you're going to get x is equal to 2 minus y. All right, so our area, if I look at the first one from 0 to y, I'm going to have y minus 0 dy. Okay, so remember its name was y, and then we're subtracting off the left side of 0. And then if I'm looking at going from 1 to 2, my right function is 2 minus y, and then once again I'm subtracting off 0. Okay, so that is what this one looks like. So we're really just integrating y here from 0 to 1. And here we're really just integrating 2 minus y. Okay, so not hard to back these up. This one's going to be y squared over 2 when we go up a power and divide by that power. And this one is going to be 2y minus y squared over 2, and then make sure we integrate that from 1 to 2. When we plug in 1 here, we're going to get 1/2, of course a minus 0, which I don't need to write. This one, when I plug in 2, I'm going to get 4. 4 squared over 2, I'm going to get 2. And now I need to plug in 1, so when I plug in 1, I'm going to get 2. Minus 1/2. Okay, so you can take a second and total that all up, and then we should get that same answer of 1 that we got in example of 1. All right, so that shows you integration with both respect to x and y. Now we're at examples where we need to get to decide what we want to do, whether we're going to integrate with respect to x or y. So I'm going to do a couple of these right now. I'm going to save a couple for class tomorrow just to make sure that everybody got the idea from this video. So the ones that I want to do with you today are A. I'm going to skip over B, and I'm going to do C, and then I'm going to wait for D in class tomorrow. All right, so let's look at the picture here. So since the pictures are drawn for us, a lot of times you can get some good hints of how they want you to do this based on how they're writing the formulas. So here we have the formula y equals x and y equals x squared minus 2. So since these are formulas y all about x, they may want us to do integration with respect to x. Which definitely makes sense because we can see this y equals x is the top curve, and we can see that this guy is the bottom curve. All right, so my area formula, don't know my limits of integration. They didn't fill them in for me, but I kind of have the structure that I'm going to take the top curve minus the bottom curve, and my variable of integration is going to be x. So to find out my limits of integration, you need to find the intersection points where this line is cutting through the parabola. So that's pretty easy. We could just set the functions equal to each other. So we can set x equal to x squared minus 2 and do a little solving. So we have 0 equals x squared minus x minus 2. And then we can easily factor that and get x minus 2 and x plus 1. So x equals 2 and negative 1 are going to be our limits of integration. So 2, we can mark that on our picture, would be the point of intersection there. We don't need to find the y value. And then negative 1 would be right there. All right, so ready to set up our integral now. We're going from a negative 1 to 2. Our top curve is x, and our bottom curve is x squared minus 2. All right, so this might be to the point where a lot of these I'm going to let you use your calculator to integrate. If you want to keep practicing the integration so you know that you have that part done, I'll go ahead and write it out. This is x squared over 2. Okay, then you're going to have minus x cubed over 3. These are all using the power rule. Here, be careful with the sign. So this should be plus 2x. That you're integrating from -1 to 2. Okay, so when you plug in 2 first, if you're doing this by hand, you're going to get 2, right? 4 divided by 2. 2/3 would be 8/3. And then you're going to get 4. So that would be the arithmetic. If you're plugging in -1, you're going to get 1/2. Then you're going to get a negative with a negative, so a positive 1/3. And then a minus 2. Okay, so working that out, you should end up with 9/2 or 4.5. All right, so that does that one. Okay, so let's jump down to C here. So C, again, we should be able to look at the formulas. So this is an x equals, so is this one. So that's a nice hint that they may want us to do the right minus the left. So if I look at it, this would be on the right side. Okay, and then the one that is in red would be on the left side. Okay, so I'm going to be doing a right minus left problem. So since I'm doing a right minus left, I need everything to be about y. So that's our formulas are x in terms of y, so that's good. But I don't know what my limits of integration is, right? I don't know what my low y is, and I don't know what my high y. So once again, I need to set the formulas equal to each other and find those places where those two graphs intersect. So I have 2y is equal to y squared minus 3. So once again, pretty easy solving. Just a little factoring. We're going to factor this into y minus 3 and y plus 1. So we can see that our low y is going to be -1. And then our upper y is going to be 3. So those are going to be our limits of integration here. So we have from -1 to 3. Our right function is given by the line 2y, and then my left function is given by the parabola y squared minus 3. Okay, once again, we can kind of cop out and use that integral button in our calculator that I showed you. If you want to do it by hand, 2y would go back to y squared. Negative y squared would go back to negative y cubed over 3. And then remember, be careful with the sign here. This would be a positive 3, so that would go back to positive 3y that we're integrating from -1 to 3. I'm going to let you do the arithmetic this time. Something good to check. Plug in 3, plug in -1, subtract those answers. You should get 32/3. All right, so that gives you an example of each one, a top minus bottom and a right minus left. Might be a good idea. We're saving B for class tomorrow. Ask yourself which one makes sense there. Okay, a top minus bottom with the way that's drawn and the way the formulas are given. And then here, this one's a little bit of a push. What makes sense here when you're trying to find the area of this region? Okay. A top minus bottom or a right minus left. All right, the last example that I'm going to do for you today in a video is example 4. This is very similar how we started with examples 1 and 2, where we're going to express the area of the region in terms of x and y both, so we know our answers are going to be the same once we're done. So since they want us to do with respect to x first, this is going to be one where we're looking at a top minus bottom. and everything needs to be about x. On this one here, we are going to do a right minus left, and everything needs to be about y. Okay, so the top minus bottom one is probably a little bit easier because our formulas are all about x as they're given. So really the only thing we don't have are the limits of integration. So the y equals root x would be our top formula, that red, and then the black would be our bottom. Okay, so our top formula would be the square root of x, and our bottom formula is the x cubed. All right, give me just a second here. All right. Okay, so this is going to be all about x. All right, so we still need to find our limits of integration. So definitely we can see that 0 is going to be the lower one. And that's not a shock whenever we set the functions equal to each other. We've got the square root of x equals the cube root of x there. So when we solve this, we go through and square both sides. So we're going to get x equals x to the 6th, and then we can take out an x. We get x to the 5th minus 1. So there's the x equals 0 that we can see from the graph. And then this one, we'll get 1 for the upper limit. Okay, so those are the x values there. So go ahead and put in a 1. Remember that the square root of x, just as a reminder, can be written as x to the 1/2. So that's important when you integrate that. So when you go up a power, you're going to get x to the 3/2. And then the reciprocal of 2/3 is in front. And then this is x to the 4th over 4. And basically all we'd have to do is plug in 1. So we just need to subtract the fraction 2/3, because 1 to any power is going to end up being 1, and then subtract 1/4, and when you do that, you will get the fraction 5/12 when you make a common denominator. Okay, so we know what our answer is going to be, so now we have to do the right minus the left problem. All right, so for the right minus the left problem, we have to look at these functions in a different way. So I'm going to go ahead and erase my top minus bottom, and now look and see who is on the right and the left. So it looks like the black function in this case is on the right. Okay, and the left function will be the red function this time. Okay, now the issue is the formulas are not all in terms of y, so we have to make that happen. So not hard to do, we just need to take the cube root. So we'll have the cube root of y is equal to x for our right function. And then for this function, to get rid of the square root, we need a square. So we're going to have y squared equals x. Once again, we need to find out how, tall we're going here. We know where our lower limit is going to be 0 again. We want to figure out how tall we're going. We could use part A, what we did, since we already have the x values. So we want to know what happens with like x equals 1, what the y value is. So you could go back to, the x cubed formula that you were given. If you plug in 1 and cube it, okay, then you're going to get that 1 is how tall you go. So same limits of integration, just looking at, moving from 0 to 1, on the x for the top to bottom, and then 0 to 1 on the y from the left to right. Okay, so our right function ended up being the cube root of y, and our left function ends up being y squared. Okay, once again, remember the cube root of y is y to the 1/3. So if I am backing that up, when I add 1, I'm going to get 4/3. Okay, reciprocal in front of 3/4. Okay, and then y squared will be y cubed divided by 3. Okay, if you want to go ahead and plug in 1, subtracting 0 will make that all disappear. So really you just have 3/4 minus 1/3. And then once again, when we find the common denominator, here I'll go ahead and do it. Okay, so it'll be 9/12 minus 4/12, and we are not surprised that we get 5/12 again. So it's nice to be able to do this in both ways because you can check that things are being set up appropriately. We'll continue working on this in class on Tuesday, so just come prepared with any questions or any things that you didn't understand about the lecture. I hope you have a great day off.